Hello everybody, this is Mrs. Snook with section 8.1, Sequences and Series. Wanted to make this a bit bigger. All right, so sequences and series. Our objectives today are to use sequence notation to write the terms of a sequence. We're also going to use factorial notation. We're going to use summation notation to write sums, and we're going to find sums of infinite series. So before we go any further, let's talk about what a sequence is versus what a series is. A sequence is a list of numbers. Something like 1, 2, 3, 4. And a sequence follows a pattern so that you can predict any element in the sequence. A series is where you add them up. This would be 1 plus 2 plus 3 plus 4. So sequence and series. Factorial notation, you should have seen this before. This is something like you have a number and then an exclamation mark, and that means 2 factorial, and that's the same thing as 1 times 2. Summation notation looks like this, and when you see that, you're going to add the elements up and then finding sums of infinite series. So that means the series goes on indefinitely. And there are ways to find the sum of an infinite number. All right, so the first thing we're going to do is we're going to write the terms of a sequence. Just want to mention notation a bit. A sub n, that means the elements in the sequence. So A sub 1, A sub 2, A sub 3 are the elements, the numbers. And then n would be the nth term of the sequence. So if n is 1, that means it's the first term, n is 2 is the second, and so forth. So what we're going to do is we're going to write the first 4 terms of our sequence. So that would be a sub 1, a sub 2, a sub 3, and a sub 4. And then notice it says 3n minus 2. So that means you take whatever your n is, you plug it in there, and then you get what that element is. So our first one, n equals 1, so that's going to be 3 times 1 minus 2. So I get 3 minus 2 are 1. So a sub 1 equals 1. A sub 2, now you put 2 in, so 3 times 2 minus 2 is 4. A sub 3, 3 times 3 minus 2, that equals 7. A sub 4, 3 times 4 minus 2 equals 10. All right, our next one is, this time instead of 3n minus 2, this is 3 plus a negative 1 to the n. So what happens when we start changing that n? So here's a sub 1. You get 3 plus negative 1 to the 1. Well, negative 1 to the 1 is negative 1. So this is 3 minus 1, and I get a 2. Now let's see what happens when I put a 2 in there. I have 3 plus negative 1 squared. So negative 1 times negative 1 is a positive 1. So this is 3 plus 1 equals 4. A sub 3, 3 plus negative 1 to the 3. Well, negative 1 times negative 1 times negative 1 is a negative 1. This is 3 minus 1 equals 2. Notice we already had a 2 up above. A sub 4, let's put in 4 for a. So 3 plus negative 1 to the 4. I get a 3. And then negative 1 to the 4, that's going to be a positive 1, so I get a 4. So notice this is alternating between 2 and 4. And it's alternating because, right there, we're alternating between -1 and +1. So when you see a -1 to the n, something's going to start alternating. I also want to point out on our first example, part A, you see the difference there between 1 and 4? That's 3. Between 4 and 7 is 3. 7 and 10 is 3. So those differences there are 3. Check that out. We've got a 3 right there. So if you see a 3 times n, that means your difference between each of your terms is going to be 3. So whatever is in front of this n here in this form, that's going to dictate the difference between each of your terms. So keep those thoughts in mind as we go forward. All right, so now we're going to do another one where we're writing terms of a sequence. This one is going to be the first 5 terms. And notice we have this -1 to the n, so we should see some alternating. And we have a 2n right there. So that means we're going to have a difference of 2 in the denominator. See what happens when we plug in and see if we get this alternating and the differences of 2. So we're going to do a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. A sub 1 is going to be -1 to the 1 over 2 times 1 minus 1. So I get a -1 over 1. That equals -1. Now let's get a sub 2. I have -1 to the 2 over 2 times 2 times 2 minus 1. That gives me a 1 over 3. Next one. I'm going to give myself some more room here. -1 cubed over 2 times 3 minus 1. I get a -1 over 5. So check it out. I'm already seeing it alternating. Negative, positive, negative. And then look at my denominators. 1, 3, 5. So my denominators are going up by 2, and my signs are alternating. Let's see if this continues. A sub 4 is going to be -1 to the 4 over 2 times 4 minus 1. I get a +1 over 8 minus 1 is 7. Pattern's continuing. Next one. If our pattern continues, then our next one should be negative, and our denominator should be 9. So we should get a -1/9. Let's see if we do. -1 to the 5 over 2 times 5 minus 1. I get a -1 over 10 minus 1, 9. All right, so our next idea is we're going to start with a sequence, and then we're going to figure out the expression for the nth term. And we say apparent expression because we're basing this only on the first 4 numbers. It is possible that we would have a different expression, but all we can do is use these first 4 terms, so we call this an apparent expression, meaning this is what we think it is, although we realize it might be different. Based on our first 4 terms, this is the best we can do. So I'm going to divide up some space. So example A. I'm going to do this first. I'm looking at 1, 3, 5, and 7. First thing we do is check for differences. So that's a 2, 3 to 5 is 2, 5 to 7 is 2. You notice that they each have a difference of 2. So that that means that in our expression, we should have a 2n. So we should have a to the n equals 2n. Now there might be a plus or minus something off the end. We'll have to sort that out. This also means that our sequence is linear. if I was to plot these points, I would have a linear expression. So let's figure out if just 2n works. So if I do a sub n equals 2n, then my series would be 2, 4, 6, 8. Now I'm going to compare 2 and 4 minus 1, 4 and 3 minus 1, 6 and 5 minus 1, 8 and 7 minus 1. So our apparent sequence is a sub n equals 2n minus 1. Let's look at our other one here. First thing I'm going to do is check differences. So 3, 5, 7. Okay, my differences are not the same. So this is not linear. So the next thing I'm going to guess, well, if it's not linear, let's try quadratic. So instead of an n, let's try n squared. So now if it was n squared, so if I have a sub n equals n squared, I would get 1, 4, 9, 16. Now compare that to what we have. I don't have a 1, I have a 2. So there's a difference of 1 there. 4, 5, difference of 1. 9, 10, difference of 1. 16, 17, difference of 1. So what this looks like is a sub n equals n squared plus 1. If I add 1 to each of these terms, I get the ones that I'm given. So that's going to be our apparent expression. All right, the next idea is the factorials, where you have that exclamation mark in there. What that means is if I give you n factorial, so some number factorial, that means you do 1 times 2 times 3, and you keep going until you get to n. So for example, 3 factorial is going to be 1 times 2 times 3. 10 factorial is going to be 1 times 2 times 3, keep going, times 9 times 10. So let's get our first 5 terms for this sequence. We have a sub n is 2 to the n over n factorial, and it says begin with n equals 0. So we have, and it says we want 5 terms, so I'm going to get a to the 0, a to the first, a2, a3, and a4. Those are going to be my first 5 terms. So I have 2 to the 0 over 0 factorial. Now our definition of factorial doesn't have a 0 in it. So what they had to do is they had to define 0 factorial. And they set that equal to 1. So 0 factorial is going to be a 1. So 2 to the 0 is 1 over 0 factorial equals 1. So a 0 is 1. Now we're going to do a 1. 2 to the 1 over 1 factorial. That's going to be 2 over 1, which gives us 2. Now we're going to go to a sub 2. 2 to the 2 over 2 factorial. 2 times 2 is 4 over 2 times 1. I get another 2. 3 factorial. Sorry, a sub 3, and I'm going to use a 3 factorial in here. That's giving me a little bit more room. So this is going to be 2 to the 3 over 3 factorial. 2 times 2 times 2 is 8 over 3 times 2 times 1. So 8 over 3 factorial. 2 times 3 is 6 and that reduces to 4 over 3. Our last one, a sub 4, that's going to be 2 to the 4 over 4 factorial. 2 to the 4 is 16. 4 factorial is 1 times 2 times 3 times 4. So 16 over 2 times 3 is 6, times 4 is 24. So that gives me 2 over 3. Okay. All right, the next thing we're going to do is simplify some factorial expressions. Just practice our factorials a bit. So 8 factorial in the numerator, that's 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. And then in my denominator, I have 2 factorial times 6 factorial, not 12 factorial. Your temptation is to go, oh, 2 times 6 is 12, not 12 factorial. Do not do that. You cannot multiply factorials that way. So what you need to do is use the definition of factorial. 2 factorial is 1 times 2, and then 6 factorial. 1 times 2 times 3 times 4 times 5 times 6. Now look and see what cancels. See if anything cancels. Well, 1 cancels with 1, 2 cancels with 2, 3 cancels with 3, 4 with 4, 5 with 5, 6 with 6. So what I'm left with, in my numerator, I have 7 times 8, and in my denominator, I have 1 times 2. So that's going to give me 56 over 2, which equals 28. The next one is a more generic. This one is n factorial over n minus 1 factorial. Again, use the definition of factorial. So n factorial is 1 times 2 times 3 times n minus 1 times n. And I'm using the n minus 1 here because I'm going to have an n minus 1 from this one. And then n minus 1 factorial is 1 times 2 times 3 all the way up to n minus 1. Stops there. So now let's see what cancels. 1 cancels with 1, 2 with 2, 3 with 3, and this continues everything canceling until n minus 1 cancels with n minus 1. So my answer is just n. All right, next up is the sigma notation. So this letter there is called sigma. It's a Greek letter, and what it means is sums. It means add up. This little I equals 1. That means start at 1. This 5 here means stop at 5. So we're going to do 1, 2, 3, 4, and 5. And this means you plug in the I right there. So I'm going to have 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Notice each one of these is a 3 times. So that means I can make it easier by factoring out a 3. It's a GCF. So I have 3 times 1 plus 2 plus 3 plus 4 plus 5. So just add these up. So 1 plus 2 is 3, plus another 3 is 6, plus 4 is 10, plus 5 is 15. So this is 3 times 15 equals 45. Our next one, we have the sum again. K goes from 3 to 6, so 3, 4, 5, and 6. And the K gets plugged in right here. So I get 1 plus 3 squared. That's my first term. Plus 1 plus 4 squared. That's my second term. Plus 1 plus 5 squared. Plus 1 plus 6 squared. That's all the terms in that sequence, and all I have to do is add them together. So I get 3 squared is 9 plus 1 is 10. 16 plus 1 is 17. 5 squared is 25 plus 1. 6 squared is 36 plus 1. So just add all those together, and we have 10 plus 17 plus 26 plus 37 equals 90. That's the answer there. This last one, we're going to sum from n equals 0 up to 8. So we're going to have a whole bunch of terms in our series here. And it's going to be 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial. We're going to keep going. 1 over 3 factorial plus 1 over 4 factorial plus 1 over 5 factorial plus 1 over 6 factorial plus 1 over 7 factorial plus 1 over 8 factorial. For this, it's really handy to be able to use our calculator. I have my calculator here, and I want to show you something super nifty on here. If I go to math, and then I come over to prob for probability, right there at 4 is factorial. So what I can do is I can just have the calculator add all these together for me. So I'm going to quit out of here. Clear this. And what I want to do is 1 over 0 factorial. Well, I know 0 factorial is 1, so that's 1. And then 1 over 1 factorial, that's another 1. And then I'm going to have the calculator do a lot of work for me. I'm going to take 2 factorial, and I want to do 1 over 2 factorial. So here's what I'm going to do. I'm going to go second. No, not second. I'm going to do, I need 2. I'm going to go math, probability, factorial, and then I need to put this all to the -1. And then plus. I'm going to do the same thing for 3 factorial. So 3, math, probability, to the -1. And I'm just going to keep going. So what I'm going to do is I'm going to pause here. I'm going to put in the rest of the numbers. And then when we come back, you'll see them all already filled in. Okay, so I have finished entering everything into my calculator. I'm just going to push enter. And look at that. There's my answer. Which is approximately E. Remember that letter E that we had, that transcendental number? That's where E comes from. All right, so the next thing we're going to do is we are going to find the sum of a series. And we're going to do it in 2 different ways. So here's where our series is defined. We have 3 over 10 to the I. Here's I. I is going to go from 1 to infinity. So this is those infinite series that I was talking about. First thing we're going to do is called a partial sum. So when you have an infinite series, the partial sum just means start at 1 and stop at whatever your partial sum is. This one's the third partial sum. So it's going to be the sum of I equals 1 to 3 of 3 over 10 to the I. That's our partial sum. So we're going to do part A here. Part B we'll do over here. And part B is going to be the whole infinite sum. So that's going to be sum from I equals 1 to infinity of 3 over 10 to the I. First one, pretty simple and easy. I know this is going to be 3 over 10 to the first plus 3 over 10 to the second plus 3 over 10 to the 3. And if you punch this in your calculator, you're going to get 0.3 plus 0.03 plus 0.003, which equals 0.333. Now the second one, example B, this time we're going on forever. So we're going to do 3 over 10 plus 3 over 10 to the second plus 3 over 10 to the third plus 3 over 10 to the fourth plus 3 over 10 to the fifth, and it's just going to go on and on and on. So our answer to that one is going to be 0.333. Just like we had before, you keep adding a 3 on the end, but it goes on forever. So there's that bar over top that means it goes on forever. Now, the way we're going to figure out what this equals is we're going to take our calculator, okay, and we're going to do 0.333, and I'm just going to keep putting in 3s, 333, as far as it'll let me. And then I'm going to go to math, and I'm going to have it convert that to a fraction for me. So I press the math menu. The first option is fraction. I hit enter. Boom, 1/3. That's my answer. And that's all there is to it. And that is it for today's lesson. Thank you for watching and have a great day.